how do we derive from our quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac over 2a? In this lesson, we'll be talking about how we use this equation to come by our quadratic formula. And in doing this, we'll be showing you how we arrive by it, and we'll be completing our square. Now you might be asking, where does the term completing the square actually comes into this lesson? Now, if you look at the term quad, quad actually means 4. And whereas quad means 4, you'll find that a square is really actually a quadrilateral, because the term quad really means 4. And the idea of saying all of that is that if we look at our equation, we'll see that in a quadratic equation, we'll see that the highest index is literally a square. So just understand that quadratics, when you hear the term quadratic, you're talking about a squared expression, right? So that's the basic thing that I want to explain, right? So looking at this equation right here, we see that we have ax squared plus bx. And just to break it right there, is that we are going to find a way where we can leave the 2x, these like terms, we're going to find a way to leave them. And we're going to do that by factoring out our a. So we're going to factor out our coefficient a from all our terms. And we have to do it right throughout. We really have to do it here, but because 0 divided by anything is still just 0, we don't really have to put anything there, right? But nevertheless, it's probably just wise that you can see it, that we're just going through by dividing by a, right? So I'm just going to leave it there. So the a's are being cancelled out right here, and we're left with x squared plus, this is going to be b over a. And you get the idea by now that we're just focusing on our coefficients right here. So we're just focusing on this for now, right? So we're just going to leave our x a little bit separated right there so we can see what we're working at. And this now, this is positive c over a. We're just going to keep that as it is. And of course, as I said before, that's going to be 0. All right, having this in play, this is a A, just not to be confused. It might look like a 9. So this now, having this in play, we can actually start to think about our square, completing our square. Now, in completing our square, and if you look here, you'll find out that this is not a squared number. X is not a squared number. It needs to be x squared to be a squared number. B over a is also not being squared. So we need to have this being expressed as a square. We need to complete the square. Now, the idea of completing the square is to understand what that really means. So this should actually be a perfect square. Should be an expression of a perfect square. And perfect squares usually is written out like this. And in writing this out, we would actually have something. This is the format in which a perfect square is actually given. So we have a squared plus, we have a squared plus ab, 2ab rather, plus b squared, right? So what you'll find out is that this b squared right here, it is not right there. And how do we go about finding this b squared? How do we go about completing this square? Well, if you were to take this 2ab right here and divide it by 2 and then square it, you would actually get your b squared. Let me just give you an example of that. Let us say, for example, we have like x plus 9. Let's start with that, right? X plus 9 all squared. And in perfect square, as I said before, that would be written as x squared plus 3x plus 3x plus 9. And that would be how it is written. So if you look here, we would literally be having x squared plus 6x plus 9. Now what I'm saying now is that if you were to take this 2ab, which would be this 6 right here, and half it, which would actually give us, which would give us 3. Half of 6 is actually 3. So if we half this 3 and then we square it, we would actually get our 9. And you can actually try different examples where that is concerned. We will, so in other words, in order to get the other portion of our square, we need to half this number, half it, and then we square it to get to complete our square. So let us do that. So in halving BA, just to some space there, in halving B squared, in halving B squared, B over A, in halving it, it means that we're dividing it by half. This, we could actually have this written out as B over 2A. And then we're going to square it. And squaring it really is going to give us B squared over 2 squared is going to be 4. This is going to be A squared. So that is what we're going to be having right there. So in other words, we literally complete the square by having this expression right here. And we're going to have plus B squared. If you realize, let me just, even in writing, I'm going to put this in orange marker. And at this time as well, just to put that there, for A squared. At this time, I'm going to actually take this C over A and I'm actually going to bring it over to here. So in bringing it over, we know we have to subtract it to actually remove it. We will subtract it and therefore subtract it on both sides. So anything that we do on the one side, we have to do it on the other side. So I just want to have this being written in this with this marker, negative C over A. So negative C over A. Now, if you look here, technically, we actually added something to make this the perfect square. Now, if we add this right here, we also have to add it on both sides to balance the equation. We always have to balance equations. So anything you do on one side, you have to do it on the next. So that's what we're gonna have right there. Now, this right here is our perfect, is an example of our trinomial. Is that a trinomial expression? Yes, and it is really a perfect square, a perfect trinomial square, if you like to call it. So, just to make some space, I'm just going to erase what I have here, right? So we can see what we're working at, right? Erasing this as well. All right, with that being done, we can now look at our work. And I must say it's actually beautiful looking at it from here, because now we can actually factorize this as when we had the x plus 6x plus 9, we literally could just, should be squared, we could literally just have this right there, and that's literally what we're going to do. We're going to factor this as a perfect square. So we're going to have x, we're going to have x plus b over, it's actually going to be over 2a all squared, right? Because the 2a, when we actually multiply everything top and bottom, we're literally going to get back this. So this expression right here is literally just all of this that is right here. So this is just the perfect square of the expressed trinomial right here, right here, right? So we actually have that. And what else do we have? We also have equals to, we have that equal to negative c over a plus b squared over 4a squared. Now, one of the things that you have to bear in mind as well is that, let's just focus on here for a little bit, is that we need to, in order for us to add fractions, we need to have fractions with like denominators. They need to have the same denominators. Now, if you look here, the negative c over a, if you look here, is that this right here, we can actually make this a right here to become 4a squared. In order to do that, in order to do that, we actually have to multiply this by 4a. And in multiplying the denominator by 4a, we also have to multiply the numerator by 4a. So what do we have? In doing that, we're actually left with bracket x plus b over 2a equals 4. We're going to have 4ac plus 4ac, right? And 4ac plus b squared. We're going to have that all over 4a squared. Because as you can see, 4a times this is going to give me that. So this is what I'm going to have right now, right? The other thing is that I need to actually remove the square sign. And in doing this, I would actually find the square root, right? So we would have to find the square root of, of this right here. And in finding the square root of that, we also have to square root the other side. So we have to find the square root of both sides to remove the square right here. So you know that the square root is going to remove that. And it's going to remove the square. So we're going to be left with x plus b over 2a equals the square root of 4ac plus b squared over 4a squared. All right. So having that written, we are just gonna make some more space. Make some more space right there. Just to make some more space. So having this right here written out as this, we know that the square root, we need to see that this right here, the square root of this, this literally is gonna give me back this expression right here. So this is actually going to be the square root of 4ac plus b squared. And this, the square root, because what happened is that this square root is the square rooting this, and it's also finding the square root of this. But if you look here, 4 is a square number and a is also a square number. So we can literally just have that over 2a. So in writing it there, we're just going to go bring that up at the top right here, and then I can just clear that to make space. So this is what we have now. 4ac plus b squared should be a negative, by the way, over 2a, right? So I'm just going to erase all of that which I have now. And just to say also is that we can actually flip this around. So just to let you see that we're going to flip this, or this right here is going to come over here. I'm just going to do that because that's how the formula is written. So this right here, I'm just going to put this over here. So I'm just going to flip here and there. So this is going to be I'm going to put the b squared here and the minus 4ac right there. Okay, so that, in case you were wondering, right? So here now is that we have, if we look carefully, we have x plus b over 2a equals, and we have the square root of that and this. Now the other thing that we can do now is that, by the way, just to say that this will be plus or minus, as you know, the root of a number, although we ask in general for the positive root, the root of a number is really a plus or minus, right? It's just that in most cases, the positive is what is required. So, but when you're talking about quadratic, using quadratic formula, we actually recommend that you have both positive and negatives right there. So that's where the positive and the negative comes in. Now here now, we actually going to remove this b over 2a because we're still solving for x. And in solving for x, we would have to subtract. We would have to subtract um, this. This is I'm adding the b over 2a. So in order to remove it, I would have to subtract it. And if I subtract it there, I also have to subtract it here. So I would have for 2a plus or minus b squared minus 4ac over 2a. Now the fact that the denominators are the same, the fact that the denominators, so these are going to be cancelled out. And just to wrap things up, the fact that the denominators are just the same, so in wrapping up and in understand that the denominators are the same, we can have everything written as negative b plus or minus the square root of b squared minus 4ac over 2a. And that is how you arrive at your quadratic formula. All right, thanks again for tuning into this lesson. Please remember to like, share, and subscribe to my channel for more math videos. Thank you.